So I'll just start recording. So this is Availability Workbench. Availability Workbench differs from Reliability Workbench primarily in the way it does its calculations. In Reliability Workbench, we use mathematical methods, standard methods like failure rate calculation, probability analysis to calculate reliability and safety parameters. So these are just standard equations where you put numbers in and the program will give you a result. Availability Workbench instead uses Monte Carlo simulation. So that's a process whereby the program will randomly sample statistical distributions for failure, repair, and maintenance in order to, simulate the real-world behavior of your system. And in that way, give you results about availability, lifetime cost, system capacity, and so on. Among the advantages of Availability Workbench, you can model strong dependencies, things that you can't model in, say, a fault tree or a conventional RBD. These things include warm and cold standby, limited numbers of spares and labor, cost calculations. It also allows you to try different maintenance scenarios so you can optimize your maintenance strategy. Again, that's something you wouldn't be able to do in the Reliability Workbench analysis. The drawback, of course, is that because it's a statistical analysis technique, there will always be statistical uncertainty on the output. And also, Monte Carlo simulation is quite an intensive process. So generally speaking, an Availability Workbench analysis takes longer than a Reliability Workbench analysis. But basically, Reliability Workbench is for reliability and safety analysis. Availability Workbench is for availability, capacity, and cost analysis. Availability Workbench, like Reliability Workbench, breaks down into a variety of different modules. The two main modules are Rcm Cost and Rcm. Rcm Cost is our tool for reliability-centered maintenance. It allows the user to build a functional hierarchy that represents their system, populate that with failure modes and the associated maintenance tasks, and then helps them to select and optimize a maintenance strategy based on cost, availability, and criticality. Rcm is the availability simulation tool. Rcm allows the user to build a logic diagram to represent the interaction between outages in a system. This can be a fault tree or it can be an RBD. The program is not doing what you might call a true fault tree or true RBD analysis. There is no Boolean algebra. There is no probability calculation. Instead, that diagram is used just to represent the way the different outages interact. So is there redundancy? Are there a train of components? Is there voting involved? So you can build that logical representation of the system, but again, populate that with failure and maintenance data, and then do a simulation to work out availability, capacity, and other parameters. Now, there are several other modules as well. Of course, there's a variable analysis tool for analyzing historical data. This works very much the same way as the variable tool we saw in Reliability Workbench. There is a Lifecycle Cost tool for doing additional cost calculations above what these two modules already do. There is a Process Reliability module for analyzing historical productivity and working out how much production is being lost due to different failure modes in a system. And there are Erp Portals So if a user is storing system information in SAP, Maximo, or Ellipse, that information can be downloaded into the software and then used to help build an Rcm model. But we'll start by looking at the Rcm Cost Module. The framework for the Rcm Cost Analysis is a functional location hierarchy, or functional familiar. It comprises locations representing systems, subsystems, and assets. You can enter information about the functions and functional failures of those assets, and then the failure modes that result in those functional failures. Building the hierarchy is very simple. It's actually very much like what we've done already in Formica. So you can go to Add, Resource, and Location, or you can just use the toolbar. You click on Add Location. You can give the location a name, a description, enter notes information if you want, and then click OK. You see the location gets added, and you can just keep adding locations in this way. So I might have a subsystem, and then I might have, say, an asset. Just like in Reliability Workbench, the program will not limit the number of location blocks, nor will it limit the number of levels that you can have. So I could keep building and have as many blocks as I want at all the different levels of the hierarchy. At the roots of the location part of the hierarchy, I can then specify the functions of that asset. So I can click to add a function, and a function is very simple. It's only a description of what the asset does. There's no information here that will change the analysis in any way. This is just for your functional familiar. So I will just enter a description. I'll just call it function 1 for simplicity. And just like with the locations, each asset can have as many functions as I want. So I can have numerous functions, just like a real asset could have many functions. I can do the same thing here. Then I can add functional failures. Again, this is the way in which the asset fails to perform the function, and it's only a description. So I might say fails to perform function 1, or maybe it might just be a partial failure to perform function 1. So I can have different functional failures associated with a function. Finally, at the root of that hierarchy, I can specify the causes, or you might prefer to call them failure modes. But these are the failures that will result in the functional failure. So I might just give that a very generic name, component wear out, or something like that. And as you can see from the dialog, the cause is actually where most of the information goes into an Rcm cost project. This is actually where the simulation is going to take place. So to begin with, when I'm defining a failure mode, I will of course want to enter failure information. So I can specify the MTTF, I can enter variable parameters, and there are different ways that I can do this. I can of course enter the data manually. I can choose the relevant failure distribution, maybe exponential for constant failure rate, or variable if I'm modeling wear out. And then once I've chosen the distribution I want, I can enter the relevant failure parameters. If you don't have much information about your system yet, but you have been discussing with, say, colleagues or clients how a failure should behave, you might be able to use the failure distribution wizard, which is this button here. The wizard allows you to choose one or more regions of a bathtub curve. and then enter some very rough information about how each region of the failure rate curve can be expected to behave. And once you've entered this information based on your discussions, the program will use that to build a basic failure curve from the data provided. On the other hand, maybe you have a lot of historical failure data, and you can import that data to the Viable module, just like we did in Reliability Workbench, do an analysis of that data, and then you can reference that Viable data set in the model. So you can select the data set, and the program will pull in the results of the analysis to use in your simulation. So there are several different ways of approaching failure data in Rcm Cost. Of course, there will also be corrective maintenance, repairs that take place to fix these problems. Here you can see when we created the cause, automatically the program created a corrective maintenance task to deal with that. I can edit that task, enter information about the task, just a description, task duration, costs. I can also enter details about the resources. So I can enter information, for example, about labor. How many people do I need for this task? So I could click edit. So I click at new, and maybe this is an engineer who I need for this task, and maybe it costs 100 to call him out for corrective maintenance, 60 for scheduled maintenance, and maybe it costs me 50 per hour while this person is working. I can also specify how long it takes the person to arrive at the site of a task. So if I wish, I can enter quite a lot of detail about the resources I need. So I can then say maybe I need 2 of these guys, and that becomes one of the resources required for my maintenance. I can do the same for equipment. These might be the tools required for the task. And I can do the same for spares. So I can add a new spare. That might be a component of some kind. I can say how much that component costs. And then I can specify information about storing that spare part. Level 1 and 2 represent on-site and off-site storage. So if I'm keeping spares locally, I can specify cost and storage information about that location. So I can say it costs a certain amount of money to store the spare part, and it takes a certain amount of time to get the spare from storage. I can do the same at level 2, where I could specify how long it takes to get the spare from maybe a depot or a warehouse. Level 3 is the supplier. So here I can say maybe it takes a week to get a new component from the supplier. There are a lot of grayed out fields. These are fields that are associated with the Rcm module. Rcm Cost does not use them, so here we don't need to worry about them. And click OK and add that. And as you can see, we can build up a list of all the resources required for this maintenance. Of course, I can also specify my maintenance plan. I can define planned maintenance, and I can define inspection tasks. Planned maintenance would be scheduled tasks that take place at regular intervals to improve the condition of the asset. So I can add a new planned maintenance task. I can say how frequently that task takes place. I might say this is just like a lubrication task, for example. I can say how long the task takes, and I can say again what resources are required. So I might say that costs a certain amount of money to do that task as well. What I can also do is specify the condition of the equipment after the repair or the maintenance has taken place. So it doesn't have to be as good as new. If I'm just lubricating, maybe I just make it intermediate. So maybe it is 90% better than it was before, but not quite as good as new. And that will move the asset back along the failure rate curve to an earlier point in time. I can also, of course, define inspections. Inspections in Rcm Cost can perform two different functions. One is that it can work like a fault-finding task, where maybe we have a dormant failure, which we can define on the failure tab, and then we can specify the inspection required to find that task. We can also use inspections to look for imminent failure. So these are condition monitoring tasks. So I can create an inspection, say how frequently it takes place and how long it takes. I can say how many people are needed, what that task will cost. But the key thing is that we now have a Predictive Data Tab. I could say it's possible for me to spot a failure up to, say, 2 months in advance. And then I can say that the probability that I will detect that failure is 95%. So I can specify the details of this inspection and how effective it is. And I can build up a maintenance plan that way. So I'll click OK, and you can see that failure gets added. And I can add as many failure modes as I want for each functional failure. Now, we've talked about the cost of maintenance and the cost of repair, but we've not mentioned the cost of the failure itself, the cost of the outage. This is handled through the effects. So I can define an effect, and I might just call that loss. Maybe it's production loss. And I can say that maybe that costs me 1,000 per hour while the failure continues. Maybe there's also an operational severity, and I can define that in any way I want. These severity values are dimensionless and represent the impact of the failure. So you might say 1 is the best case and 10 is the worst. You might say that 10 represents 10,000 barrels of oil lost or something like that. But this information can then be used by the program to work out the criticality of the failure. I'll click OK and go back to my cause, and on the Effects tab I can add an effect, choose the effect I want. I can even specify what types of outage it applies to. So I might say here, this effect only applies to failures. I can click OK, and I can have a list of effects here. So this one failure could have multiple effects. Let's go back to the Strategy tab now. The Strategy tab allows us to view the strategy we have in place for this failure. So I could, for example, take a look at my planned maintenance on its own. So let's say I'm just doing planned maintenance currently, so I'm lubricating the asset once per year. If I analyze this cause, we can see that the cost-benefit ratio of this maintenance plan is 0.17. This is the ratio between the cost of this cause, which you can see here, calculated with the maintenance, as you can see there, compared to the cost of the cause if we allowed it to run to failure. And we can see here this is much less than 1, which means this maintenance plan is worthwhile. So it's worthwhile for us to do this maintenance. what we could do is optimize that maintenance. We could tell the program we want to try 50 different maintenance intervals at 1 month increments. So here what will happen, the program will do a complete simulation of this cause with a maintenance interval of 1 month. Then it will repeat that process with an interval of 2 months, and so on up to 50 months. And then it will plot the cost of the cause against the interval that we've tested. So then we run that, and you can see the program is recommending that we do the maintenance every 6 months. So if we accept that recommendation and run the analysis, you can see now the cost-benefit ratio is much lower. So that is even more cost-effective. However, maybe there is an alternative maintenance strategy that's better again. What we could do is turn off the planned maintenance and turn on the inspection. The inspection, if during the simulation the inspection finds an imminent failure, it will trigger any PM task that has the secondary action checkbox turned on. So if the inspection finds that a failure is imminent, it will start a PM task to prevent that failure. We can optimize this as well. So I might try sort of 50 one-day intervals and see how that works. So maybe we need to try longer intervals than that. We'll try 1 week intervals and see if that's any better. So this is saying maybe we should do the inspection roughly every 2 months. So we accept the recommendation, try that, and we can see this cost-benefit ratio is very good, but maybe the PM is still a little bit better. So Rcm Cost here is making recommendations about how frequently to do the maintenance, but also it can suggest which maintenance strategy might be the more cost-effective. So let's take a look at a more complete project. And maybe we'll take a look at that one. So here I have a choke valve, and it has a function, various functional failures, and various failure causes. One of the other things we have here as well is a viable data set. Again, this is just like what we saw in a reliability workbench, where we import historical failure data, do a line fit to that data to get the failure parameters, and then share those parameters with Rcm Cost. The only real difference is that the availability workbench viable module has a lot more distributions in it than the reliability workbench module. This is because availability workbench uses simulation, so it can model more complex failure behavior, whereas reliability workbench uses analytical techniques, so it can only handle relatively simple behavior like the 4 distributions at the top here. But we can create this data set, analyze it, go back to Rcm Cost, and then here on the breakage cause we share that viable data set, so we can see it's pulling in the failure data from that analysis. We've also set some other things up as well in the project options. Here, for example, I can tell the program what the lifetime will be. So I'm saying the life of this system is 20 years in hours. I'm breaking that lifetime into 21-year periods for my cost profiles, and I can set the number of simulations. One thing we said we could do earlier was use effects to work out the criticality of our system. We could specify the severity of failure, And the program would use that severity to work out criticality. And in fact, if you look at this optimization plot, you can see environmental and operational criticality is being plotted alongside the cost. What we can do in the simulation tab is place targets or limits on the criticality. So here, for example, I'm limiting the operational criticality to about 0.1 per hour. And we can see those limits on our optimization plot. So we can make sure that for the recommended maintenance interval, our criticality targets are not being exceeded. So that's a way in which the program is helping you make maintenance decisions based not only on cost, but on criticality as well. You can also model net present value. So as time goes on, naturally the value of resources and the value of money will change. So you can include that change in the net present value tab. You can have escalation costs, and you can have net present value yield as well. And that will be taken into account over the life of the system. So let's analyze this model. So this green button, just like in fault tree or RBD, analyzes the whole project and returns a result. So here are the estimated costs and criticalities of my system over its lifetime, broken down by the different contributing factors. I can see availability data for the different causes. I can see occurrence, cost, and criticality data for the effects. And I can see usage information for spares and for labor, so I can get an idea of how many spares I might need and how often I need to call out my engineers. Now, as well as maintenance optimization, the program can also do spare part optimization. Here, for example, we've optimized the choke valve, the spare choke valve. Here what we're doing, instead of optimizing against time, we are optimizing the number of spare parts that we store on-site and off-site. Here I'm asking the program to see what would happen if I stored between 0 and 5 spares at level 1. So the program will estimate the cost of the system if I store no spare parts. So if I just order spares as I need them, then it will try storing 1 spare, then 2, and so on up to 5. And you can see the program estimates that storing 1 spare part is the most cost-effective thing to do, because if we store no spares, we get high unavailability costs because we don't have enough spares, so we have to wait for new ones to arrive from the supplier. Alternatively, if we store a lot of spares, we get high storage costs. So this is helping us balance between those two cost drivers. And if we accept that recommendation, the program will update the capacity at level 1, and if you've optimized level 2 as well, it will also change level 2. We can also view other plots, so I can see cost profile. So this is how the cost of the system changes over the lifetime, and again that's broken down by the different contributing factors. I can look at labor profiles. I can look at cost contribution. So I can see how much each failure is contributing to the total cost over the lifetime. And of course, for more details, you can view the reports as well. So that's an overview of the Rcm Cost Module. Do you have any questions about that at all?
Yes, I have a question. For the Rcm curve, the AB simulation, mentioned. Sorry,
could you repeat that? It's a little bit quiet.
Yeah, we have to optimize. Okay, one curves are there. Exponential curves or by.
Yes.
Sorry. Hello.
Yes. Go ahead.
Yeah, we have defined some curves also, no? Based on the output, based on the inputs from the this customers, all these things. So how that can be changed, or how does it behave?
So when you say you've defined curves based on the customer data, do you mean you've done a viable analysis of the customer's historical data?
Right.
Right.
Exactly, this is not the thing. In the last module, we have seen AVSIM, right?
Yes. So I did we look at AVSIM in the last video?
Yeah.
Okay.
In that, when we were there in the AV simulation module,
Yes.
we were doing some analysis on the curves. Like we need to give some input curves. So how it can be given, how it behaves likewise in the AV simulation.
Yep. So the simulation at the block level is exactly the same. So in AVSIM, when we were defining the failure curves, like you can see here, you can see actually this information is exactly the same as the information that you can enter in Rcm Cost. So the curves are the same, the simulation is the same. The only one curve or the only one behavior that you can't use in Rcm Cost is the buffer. The buffer doesn't work in Rcm Cost because that requires redundancy, and Rcm Cost doesn't model that kind of logic. But all of the other failure curves are the same in Rcm Cost as they are in AVSIM. And in fact, if you build an Rcm Cost project, you can go to Tools, Convert, and then convert your locations to a block diagram. So here you can see the program has created a reliability block diagram based on your Rcm Cost Module project, and you can see that the failure models have the same failure curve information as the Rcm Cost model, so it's exactly the same.
And location over here, what it represents exactly? Location is the system only?
Locations can represent different parts of your system. So often it would look a little bit like this, where here, for example, the wellhead is a system, the Christmas tree is a subsystem, and the choke valve is an asset or a location. An asset or an equipment. So
asset. What do you mean by asset over here? Asset is?
Well, that's a term that's often used to describe a piece of equipment in a system. So, for example, some people might describe a pump as an asset. The pump itself is made of different components, but generally the pump is the equipment upon which you perform your maintenance. So when you say set up a work order for maintenance, it would be against the pump, and so the pump would be the asset or the equipment. Asset is the term that's typically used when people are working in the Maximo ERP system that stores their asset data. As the equivalent term in SAP would be equipment. So basically the asset is the equipment within your system.
Okay. And whenever we are doing any analysis, right?
Yes.
We define system, subsystem, and asset over here, right?
Yeah. Well, this is not this is not mandatory. You don't have to do it like this. You can have many more levels, or you can have fewer levels. This is quite a common way to do it. I think a lot of people limit themselves to maybe no more than 4 layers of locations, not because it's a set standard, but because that's maybe the most wise thing to do from an organizational perspective to stop your analysis from being too complicated. So something like this would be the most common way to do it, but it's not mandatory.
So we can start it from the asset directly and do our analysis?
Yes, if you wanted to. I mean, I could just move this to the top level. Okay. So you can see I could just have choke directly underneath locations and just ignore that and just do it that way. The program has no problem with that.
That is fine.
Okay. So I guess if we've looked at Rcm previously, then maybe we'll take a look at Lifecycle Cost. Lifecycle Cost is actually a relatively simple module. There's not a lot that you need to see here really. It's basically what this module does is it allows you to perform. Sorry, go ahead.
Yeah, I have a question. Like for the Rcm, if the customer wants to only Rcm, reliability centered maintenance, okay. So does it relevant directly with the Rcm cost?
Sorry, could you repeat the question, please?
Yeah, if customer says that we have a requirement for the reliability center maintenance,
yes,
right, software. So from our
hello.
I did.
Hi there.
Yeah, you can hear me now.
Okay, so you were asking if Rcm Cost would fulfill the requirements of a customer who needed to do reliability-centered maintenance. Is that right?
Yeah.
Yes. So Rcm Cost is a tool to assist with reliability-centered maintenance. So the way it's structured would allow them to follow the Rcm process of selecting assets for analysis, specifying function, functional failure and failure cause, the effects of failure, maintenance strategies, and then help them to improve that maintenance strategy. So Rcm Cost is a tool designed to help with Rcm.
So we have a lot more functionalities that has been involved only with the Rcm tool and right? That's the advantage. Is it?
Yes. So the advantage of Rcm Cost is that it is a tool that's kind of optimized to assist with Rcm. We believe there are other tools on the market, but I think for the most part, Rcm Cost is a lot more user-friendly than some of its competitors. And it also has the advantage of there being connections available to the likes of SAP and Maximo, which can make the process of building these hierarchies much easier because the user doesn't have to transcribe the data manually or even do a sort of two-stage import. They can connect directly to their asset management system and download this data straight into Rcm Cost. So there are a few advantages to this tool.
Okay. So, and other tools also includes this spare part optimization.
So I've not come across any other tools with spare part optimization. I can't say for sure that others don't have it, but I know that Rcm Cost, I've not seen others doing it the same way that Rcm Cost does.
Okay. And okay, yeah, Prakash. I came to know from Janet that we have discontinued Prakash.
That's right.
Yeah. So if you want to recommend any product, if the customer asks this Prakash kind of thing, can we recommend any other product we have for what is?
Well, we don't have any tools for Fracas at the moment ourselves. I don't know what other tools I would recommend for it. I think there are other tools available, but I'm not aware of any. We discontinued Fracas some years ago, and it hadn't been updated in some time before that. So I haven't really used. I haven't really got much experience with it myself.
Okay. And one more thing, like we have SAP integration, right?
Yes,
SAP integration. But
that's right.
cases, if the customer has Team Center, Siemens Team Center, or Windchill as the PLM product, right?
Yes.
Be able to integrate our there.
So sorry, could you just repeat that?
Like SAP, we have the direct integration with the SAP tools.
Yes.
That is fine. But if the customer has because some customers might be working on the Team Center or Windchill, PTC, right? Siemens Team Center or PTC, right? This PTC Windchill, if they have as a PLM product. So our product can be integrated with their products.
Well, we have built-in integration for SAP, Maximo, and Ellipse. We don't have anything for Team Center or Windchill. Now, what we do have, again, we have the API, the programming interface. So it may be possible for a user to design their own dashboard for the transfer of data between one of these other systems and Availability Workbench. They could do that using C# or Visual Basic. So we don't have direct integration, but we provide tools that might allow a user to develop their own integration if they wish.
Okay, we have that facility. Okay. We can proceed further or
Okay, so Lifecycle Cost. This is a tool for doing additional cost calculations over and above what's done by Avsim and Rcm Cost. So Rcm Cost and Avsim deal with the cost of maintenance and the cost of downtime, but they don't take into account costs beyond that. So for example, if you wanted to include the lifetime cost of things like power consumption, renting floor space, renting equipment, annual salaries and things like that, you could transfer over to the Lifecycle Cost module and introduce all of those concepts. So to begin with, you could define global variables. These are values that you want to use in your cost calculation. So for example, I could have a salary, and that might be a certain amount of money per year. I could click OK, and I could maybe add another variable, and I'll call that salary 2 or something like that, and give that a different value. I can even create global variable types. So I could create a type, maybe call that salaries, and just include those two values in there, so I can organize my my variables into types. So I could have another type called rent, say, and I could have floor space rental, which is maybe a certain amount of money per hour, and then maybe I could have I don't know, vehicle rental, and that's going to be a certain amount of money per hour. So I can create these global variables and use them in my calculation. Now the calculation itself is performed in what we call cost nodes. I can create a new cost node from the toolbar, and then I can specify my cost, cost using a cost equation. The cost equation can reference a variety of different variables and parameters. These set variables are listed in the help files, and they include things like time interval, things like sum of child costs, which will automatically add together all of the cost nodes beneath this one. So I might call this, say, total costs. And then underneath that, I can create more cost nodes. So I might call this one, say, labor. And in here, I can build a cost equation. So I might have, say, 10 people on salary 1 and 20 people on salary 2. So I can type 10 times, then I type G dot, and I can choose the variable type. So I choose salaries, then I type dot again, and the program shows me all the variables in that group. So I could choose salary, then space, add 20 times G dot salaries dot salary 2. Probably, yeah, so that's going to cause a problem. I shouldn't have put a space in that variable. Let's call it salary 1 and 2. Whoops. So yeah, I can create that cost node again, and I'll make that 10 times salaries, salary 1 plus 20 times G dot, whoops, salaries dot salary 2. But then I might want to add to that the cost of labor that I calculated in, say, Rcm cost. So I can go add, then R dot, and it will show me all the Rcm cost calculated values. So I could add to that, let's see, total labor costs. So what will happen is that when I run the analysis, the program will add the cost for each lifetime interval. So you remember, I set a lifetime of 20 years with 20 intervals. So the program will add this for every year of the lifetime, where the total costs will be divided over that period. So I can click OK. Maybe I'll just rename that to labor. OK. And then I might add, say, rentals. And that might be, say, G dot What have I added here? Oh, so I'm adding a global variable. So add cost node, and that's going to be rentals, and I put r dot, g dot rent, and then floor space, and I might be renting a certain number of square meters of floor space, and I can multiply that up, and then I can add to that maybe vehicles. So maybe I'm renting 10 vehicles, and I can do rent, just type it in, then vehicle, and then I might want to add to that something from Rcm Cost. So I might choose, for example, the costs I've put into equipment. So I might be renting cars or trucks, and I can introduce the extra costs with those as well. And these functions, so you've got multiply, add, you can use subtract, and divide, of course. You can also raise things to powers. You can also specify phase. So go ahead.
What represents G over here? G and R?
So G is G is referring to global variables. So I'm saying this is a global variable. It's in the rent global variable type, and I'm using the variable vehicle, which is here. R refers to Rcm cost. So I'm pulling the total equipment cost out of the Rcm cost analysis.
Okay. So this G and R is a standard terminology, or it is used for our software only?
It's our software. It's just a abbreviation that makes it easier to build these calculations. And I put something somewhere that doesn't make sense. Oh yeah, that's because I've got that.
So in that sense, we need to educate the customer regarding this, as this is for our software, while in training itself.
Yep. So they would. We'd need to obviously show them how this would work, but of course the help files provide information on how to do this. So here, for example, you can see global variables are preceded by G, Rcm cost variables are preceded by R, and so on. So we provide that information in the tool. You can also tell the program things like after, say, 1,000 hours, I want to add something extra. So I would say, I want to add, say, 50,000 after time, let's say after 1 year. So I can use square brackets to tell the program to introduce a one-off cost after a certain amount of time. I can do that by phase as well. So I can break the life into phases and say after phase 1, add this much money or something like that. So I can analyze that, and you can see the cost over the lifetime, and you can see the spike there where I've added that extra cost. I can alternatively change that view so that it is cumulative, so I can see the cost building over time. And I can show different sources of costs. So as we said earlier, I could add, say, rental, and then again just add those variables. So floor space plus 10 times G rent vehicle, and then I might add equipment costs. Oops, that's on total. Okay. And then I could run again and see both of those costs side by side. So I might choose to show, say, labor and rental. So I can see those shown in my plot side by side and how they change over time. So again, this is a tool just for introducing additional costs not covered by a conventional RCM or availability analysis. So do you have any questions about that?
These global variables and okay, these are the standard terminologies.
Again, this is a module of our own devising. So it's things like global variables and cost nodes. These are terms that we've, I guess, decided to use for these different parts of the tool. So I don't think that there is a standard you could go and look at that would show you these exact terms necessarily, but it's just a terminology we use to make the tool easier to navigate.
Okay, and we can transfer any data if required from Rcm Cost to or Rcm to this. Or,
That's right. So if you type R dot, you can see you can pull in any of the cost values from Rcm Cost, or if you type A dot, that will show you the cost variables coming from Avsim.
Do we have this listing available, standard listing, chart of these abbreviations of this lifecycle cost? Listing available, standard, or available directly, or we need to go to help on this?
Yes, so the definitions of everything can be found in the help. So let's see, the reserved variables is a useful one. This will show you all of the variables that are available, including things like you can reference the lifetime of the analysis, and you can also reference the interval length. In our case, that would be a 20-year lifetime with a 1-year interval length. And then, of course, you have some of child costs. You have the individual costs from the different modules. So, yeah, so all of those are listed here. So do you have any more questions about lifecycle cost?
No, it's a simple no.
Okay. So I'll show you then a little bit of process reliability. So this is an analysis technique based on a research paper by Barringer. What it allows you to do, it's a little bit like variable analysis in a way, in that it allows you to import historical data. However, in this case, the data is not failure data, not as such. Instead, it is capacity data. So here, for example, I've got capacity, cause, and record date. The capacity field is saying what the production was on the specified date. So on the 1st of January 2010, we might have produced 838 tons of product. On the 2nd of January, we produced 830, and so on. In the middle, we have the cause of any loss of capacity that day. So maybe my maximum capacity is 1,000 or 900 or something like that. But I'm below that because of the cause with the ID system 3. So you can see those here, various different causes. Now it's important. I'm sorry?
These causes are already predefined?
It's not in the software. The user would be importing this from their own data. So they would know, okay, this loss of capacity was caused by a failure of the hopper. And this one was caused by a failure of the secondary pump, and so on. So they would specify the ID of the cause and just make sure that they are consistent. So the cause ID, if 2 separate days of losses are caused by the same problem, they would have the same ID. That's all that means.
Okay, and different companies may be having different cause IDs. Or
yes, that's right. So they would have their own IDs presumably for the different failures that might occur in their system.
So in that case, our software is capable enough to identify that cause IDs, or?
Well, this is just a text field. So basically, whatever their cause ID is, they can just import it, and then the program will know that all of these days were caused by the same problem, and these days were caused by the same problem, and maybe this one and another one down here somewhere, they were caused by the same problem. So the program will recognize then that these data points are linked by a common cause. Now, the big difference when you're importing this data compared to Viable, in Viable, it does not matter what order the data is in. You can enter the data in any order you want, and it will just be the same. In process reliability, it has to be in time order. So you have to go in the order of the date in your time value, in your data set. So you can see there, it's just counting up through the dates throughout the year. So time ordering is very important. So what the program will do is it will use a process similar to Viable, and it will plot a cumulative probability plot. So for each capacity value, the program will estimate the reliability of the system at that point in time, or at that level of capacity. And you'll get a set of data that looks a bit like this. Now, there are a couple of other things you can do. In the actual data set itself, you can specify the nameplate. This is, I guess, the ideal scenario, I guess. This is what you're aiming for. Now, if you look online for the definitions of these parameters, particularly what you might look for is a shape parameter, because I think Barron just specifies different shape parameters as being at different classes. So I think if you want 50 or more, you're looking at world-class productivity. And then there are lower levels that you might aim for if it's not so critical. But the user will be able to maybe look into this and see what the shape parameter is they're aiming for and what the ideal level of production is that they want. Now, you can also ask the program to auto-fit the production level. So this is the highest level of production in your data set, which you can see here. So that you might call the normal level of production that you achieve, which is just below nameplate. And the program would fit this last bit of data to get that. So I'm going to get rid of some of these for a moment, and I'll explain what that all means. So right now you can see Production Cusp is not defined. Cusps are points in time or points in capacity where the trend changes. So you can see a very clear one here, for example. Now, that will represent the boundary between one cause of lost capacity and another. And you would have to identify these by eye. That's how this process works. So the user would look at the data, maybe they'd use the plot options to zoom in a bit, and they'd say, well, okay, the first cusp is about here, and that might give you the production cusp. So this data is your production data, and the program fits that and gives you your production estimate. You might say the next one is about here. And now the program starts estimating where your losses are coming from. So you can see 75 tons is being caused by this data. And then maybe we're losing, say about here, maybe. The next 31 tons are down here. And you basically mark these cusps, and the program works out what the losses are in each of these regions. And then you can use that to identify where your losses are coming from and try to improve that behavior. So that is really all the process reliability module does. Process reliability does not share any information with the other modules. So it is not like Viable in so much as Viable lets you pass the result of the analysis to Avsim or Rcm Cost. Process reliability doesn't do that. There's no information here that the other modules could use. However, what you can do is transfer capacity profile data from Avsim. So you could actually simulate some data for your process reliability and just take a look at it, see what the impact is of the different outages in your system. So maybe I'll even try doing that and see what happens. So let's go to this option. That's a good one. So I can analyze that project. I'll just give that a few minutes to finish. In fact, I might abort that. So I've set a lifetime here of 20 years, and I might want to split that into days. So I'll see if I can. Maybe that's too many, but we'll give it a try and see what happens. Oops, wrong one. Where is it? 75200 24. So yeah, we can do that. So we can set the profile intervals to 7300, analyze the project, and probably that's enough. So here is our capacity profile, which will change here. And maybe we'll just look at the oil and gas system only, and we'll not show the error bars. So there's my capacity data. I can go back to process reliability. Let's see what happens if I transfer. I have to create a process set, and then do that. I'll select it for oil and gas. Okay, so you can see there's some pretty clear cusps. So I might say there's one cusp here, there's one there, and so on. So I could actually, you can see there actually the whole thing is nameplate because that's such a sharp drop because it's kind of artificial information. But you can see there, you can basically pull data, hypothetical data out of Avsim and analyze that in the software. I might need to maybe set a slightly more reasonable shape parameter. But yeah, that's basically the way process reliability works. It's just a module that helps you look at your historical productivity data and try and identify which failure modes are contributing a lot to loss of capacity. So do you have any questions about that at all?
That is fine. I just want to understand that this graphical representation we have received from the data input for this process reliability, right?
Yes.
Oh, okay. A user or any this is mainly applicable for the production department, right?
Yes, that's right.
Okay. So by looking at this curve, cumulative probability curve, what understanding any production manager or any production person who's handling this data, he should get the logical understanding and exactly.
Okay, so what this is showing you, firstly, this green area is showing you where you would like your production to be if possible. And that's your nameplate data that you enter manually into the data set. So you want all of your data to follow that line if possible. Now, what you're actually seeing is you get this first set of data here that you would expect would represent just efficiency problems. So in a real system, you're not going to meet your nameplate because there will be little efficiency problems that keep you from meeting your full production, not necessarily failures, just issues with efficiency. So the program fits that data and you mark that, you say that data ends here, and the program fits it, and that blue area is the difference between your current productivity based on efficiency problems and what you want to achieve. And the program shows you here what the difference is. So you're losing about 6 tons per day due to efficiency problems. So that's what the blue part tells you. From here on, these different cusps represent different causes of lost capacity beyond simple efficiency problems. So these might be actual failures or outages that happen. So here the program fits that area and it says, okay, this area is being caused by one problem. So you can see you're losing 75 tons because of whatever is happening here. And then you can look at those data points in your data set, and I can look at that and I can see, well, most of those problems maybe are coming from the system 2 failures. So I can go up, maybe it's a bit further down than that, maybe. So I could basically work that out. I can work out, you know, they're mostly coming from system 3 failures. They're mostly coming from system 2 failures.
Okay. And how we identified that it is coming from system 2 failures?
Well, basically, these data points are in capacity order, so I could just resort these. Might make it easier. I will sort by capacity, and maybe I'll do that descending. So I can see my first cusp is at 804, and my second one is at 307. So between about, say, here and, you know, down here, I can work out where the bulk of my failures are coming from.
Okay.
So I might see most of it is PM, or I might see most of it is a particular type of failure. But it just helps me to identify where most of my failures are coming from that are causing these problems. Yeah, so most of that appears to be PM. Some of them are failures, but largely it's this. My actual PM outages might be causing a lot of that. You can see the stuff down at the bottom here, that this failure that's causing about 6 or 7 tons a day are caused by these problems.
Hello?
Hello? Okay. So is that okay?
Yeah, that's fine.
Okay. So really, the only other modules in Availability Workbench are the portals. So the two primary portals are SAP and Maximo. I will open up, I think I've got some example data for at least one of them. So the SAP portal allows you to connect to SAP using your regular credentials and then to download data from SAP and use that in your analysis. So here you can see where you could enter your login details. You can enter information on how you want to filter the data from SAP. So you can see that you can filter things like the download information. So you can say you only want to download your causes, or you only want to download your functional locations, or you can choose to download everything. You can filter the different types of equipment and spares and things like that. You can filter on your work orders. Everything that comes down from SAP can be filtered because, of course, the SAP system could contain a lot of data. So you need to focus on the things that you want. Once the information is in the portal, you can view it here. You could say, take a look at some of your locations and see the data associated with those. The developer has tried to make these dialogues look as much like the equivalent interface in SAP as possible. So user should be able to identify the data reasonably easily. You can also, of course, download equipment data. Again, this is similar to what you would see in SAP. You can download catalog profiles where your failure information is stored. You can download effects, labor, spare parts, and of course maintenance plans. These represent the maintenance tasks you'll be performing in your system. The other thing the program downloads is work orders. So I could change my grid view to show maintenance orders, and that will show me work orders of varying types for all of my assets, all of my equipment in the system. Now, all of this information can be passed to Rcm cost or viable analysis. So I could, let's say, grab this bit of my system and then build that data in Rcm Cost. If I go to Rcm Cost now, you can see the program has built that structure in the Rcm Cost module. You can see at the same time, it's also brought through the appropriate bills of materials as well, along with the associated spares. So I can go back to the portal and I can download the causes. So I might grab the catalog profiles, and download, maybe I'll take the catalogs too, and download the causes. So I'm not sure if these are going to have causes attached to them, but we'll give it a try. Let's expand all of those. Now let's go back to SAP, and then we'll take all of that. Let's just take everything. Let's select everything, and I'll download locations. Then I'll download causes, and then I'll download my maintenance plans. You can see it's in the process of doing that now. So if I now go to Rcm Cost, we can see all the causes are there. If we use the grid, I can view all my scheduled tasks. So it's not just the failures and the locations that are coming down. The program's also pulling in the scheduled maintenance as well. So that's just updating the grid because there's quite a lot of data that I've just downloaded. So effectively what we've done is build a project directly from SAP. We can also, if we wish, say, I don't know, let's take a look at some of our assets. Let me see if I can find one with some valid data. That one. So I could look at these work orders and I could do a calculation, and where there is valid data, the program will work out the time to failure from those work orders. There's got to be something a bit better somewhere, I think. There's very little in here. Let's just work with these few points. So I can then click to build a viable data set. And if I go to viable, you can see the program's created a viable data set with the viable data points in it. And I can fit that data. They're all suspended data points, so I can't do that. That is because they are all PM tasks. Yeah, I mean that's another thing the program can do, is that when you download this information, you can see these are replacements and not failures. So the program recognizes that and creates suspended data points automatically. I'm going to try to find will that work? So this information here maybe. No. There's something valid in here somewhere. Okay. So I mean, basically, what the program is letting you do is build. What's the word? Is to build work order. So maintenance is to build viable data sets based on your historical failure data. So I think this one maybe has some valid data in it. Yep, we can download that one. And then we can go to viable, look at that data set, analyze it, and you can see there the program basically as it fits the data and tells us the failure data, and I can pass that back to Rcm Cost. So in essence, the SAP portal and also the Maximo portal, which works in a very similar way, but with Maximo instead of SAP, lets you build an Rcm Cost project from data that you've downloaded from SAP. You can maybe optimize your maintenance plans in Rcm Cost, come back to the portal, and then there are options to upload data back to SAP. So you could download data from SAP, optimize your maintenance strategy, then upload that optimized strategy back into the SAP system. And this portal is certified by SAP themselves. So they've looked at the portal and said, you know, that it's okay. It's following their rules for connecting to their system. So we've got official SAP certification. And yes, that's it really. That's an overview of what the SAP portal can do.
Okay. This customer should have the SAP SAP implemented to use this SAP portal what we have, right?
That's right. So you would need SAP installed in order for the SAP portal to be of use.
Okay. And if any other systems are there, like Oracle or anything, with connectivity for that?
We have connectivity for SAP, Maximo, and Ellipse, but not currently for any other CMMS or ERP systems. But again, we have the API. So if the user has the skills to do so, they could write their own solution to connect the two systems together if they wish.
That's fine. Hello?
Okay. Well, that's everything I was going to show you in Availability Workbench. Are there any questions about any of the things that we've looked at all?
Right now, no. But if anything is there, that I'll come back to you.
Okay.
So are we finished so that we can actually I wanted to discuss like if we can set up the recording of this, then we can discuss.
Okay. So I'll do that now if you bear with me for a moment.